السلام عليكم ورحمة الله. رمضان كريم عليكم جميعًا. Good evening, everyone. Today is the first day for the Azir Medical Company online course. So our course today is about the ELISA 800, looking for the features, the indications, and what is the indication for our ventilator in ELISA 800. And tomorrow, the second day of our course, will be focusing in Leone Plus, what is the high frequency principles and the features of the high frequency principles. So welcome to everyone for the first day in our course. And just before we start our course, I need just to give you a brief about our medical company. Azir Medical Company, it's focusing in medical product, respiratory and anesthesia product. So it's founded by engineer Saad Al-Anazi in 2012, and it is partnership with many leader company in medical, such as Lovenstein in Germany and also in United States. So before we start the presentation, I will just give you, we will have 50 minutes for the course, for the presentation, then we'll take 10-minute break. After that, we'll continue with our presentations. Then in the last 10 minutes, we'll allow for the participant to open the speaker and to ask about anything. So now we'll share our slide with you. Thank you so much. الصوت واضح؟ اوكي ممتاز. واضح معكم الشاشة؟ الشاشة واضحة؟ طيب. So starting our نتأكد بس. Okay. Starting our presentation, just before that, we need to give a brief about the Lovenstein Medical Company. It's the partnership with the Azir company in Saudi, local Saudi, is focusing in anesthesia and respiratory devices. So today we are will give the presentation about the ELISA family, focusing in 800, ELISA family 800 ventilator. So anyone see the presentation, or there is any issue with the presentation? Have you seen? Please write in the chat. You see the chat? Okay, excellent. Okay. So here in this slide, you can see we have the ELISA family. ELISA family, it's around, we have the mid-range, which is 300, ELISA 300, and the 500, we have the basic range is the 500 and the 300, and we have the mid-range is the ELISA 600, and we have the advanced modality is ELISA 800, which is the one we will focus more in this presentation. So as you see in this slide, ELISA family, different devices. For the 500 and the 600, we have ELISA 300, 500 is only have the features is only air turbine. So that's all you need from you. Air turbine is the basic, can be used in can be used in the ward, ER, and also can be used in general ward. For the air and oxygen, we can use the ELISA 600, 800, which is the focus in ICU ventilators. So what is the ELISA family, the new features for that? So the new features, we have volume CO2 loops, we have the CO2 side stream, we have gas analyzer for the ELISA 800, we have the weaning tools, as you see is the spontaneous breathing tools, and we have also a different mode, a special mode, for example, the proportional adaptive pressure support. We have work for breathing optimized ventilations. We have also SpO2 integrations with the Leo clock. All these features we will explain it in the next slide. So for the ELISA 300 and 500, it's the mid-range at intensive care respiratory with the 12 and 15-inch touch screen. So it's focused on only turbine. That means all you need from you gas, oxygen plug. As you see here, we have the ventilation performance. What is the ELISA family can give to the patients? There is a many features, many performance can help the patient and improve the outcome for the patient. For example, we have a 28 mode. So the end user can be select the 10 most common mode, and they can see here, as you see, we have all types of mode. For example, volume controls, SIMV, optional volume controls. We have mandatory bi-level. We have pressure control, SIMV. We have advanced mode, ABRV mode. We have also high flow. Plus the NIV mode, we have a 13 mode can be selected during the NIV modality. Ventilation performance. What is the ELISA 800 can give to the end user? Here you can see the ventilation performance. There is a lot of features, a lot of modality can give to the patient. For example, the automatic suction routines. There is a two ways of the automatic suction routine, closed and open. We have a tube compensations. We have also inspiratory, all the maneuvers can give inspiratory hold, expiratory hold. Types of the recruitment, we have two types of recruitment, pressure recruitment and the beep recruitment. So we have beep finder, which is unique, and the first ventilator can give the beep finder. We will explain it, inshallah, later in this our lectures. We have a mini analyzer, for example, entitled CO2 multi-analyzer. We have also loops, and we have the screen shot for the suctioning, for the functioning can be used for this ventilator. So as you see here in the right side, the ELISA 600 and 800 is the bigger screen with 18.5 touch screen. And in the basic range, in the mid-range, you can see the 300 and 500. It's only small screen is 15 and 12 inch touch screen. So starting with NIV change, as you see here, if you want to start to ventilate the patient, you need to enter your patient informations. In the right side, you can see we have to enter the patient informations. Then after that, you need to select what the patient interface. As you see in the ELISA 800, we can choose a many interface tools. For example, high flow. The first ventilator can give helmet therapy is the ELISA 800. We can choose also the interface for ELISA 800. We have a non-invasive, and we have endotracheal and the tracheostomy tube. After you select all this information, you have to select the compensations percentage for the patient. Then after that, you need to select the diameter of the endotracheal tube or the tracheostomy. Why? Because they will calculating the resistance and the compliance for the patient to overcome the resistance for the patient. So after you did this, then after that, you need to what? To enter the patient intervention. What is the new patient here ventilation performance? As you see in this screen, we have in ELISA 800, we have the features as a default setting. Default setting, that mean if the patient is standard, that mean he doesn't have any issue with oxygen and the CO2, you can start the default setting by this setting, rate 12, inspiratory time by 1.5, and the beep 5 and FI2 50. If you select the oxygen, that means patient having issue with the hypoxemia, so the default setting, they will start with the higher beep and higher FI2. If the CO2 is the hypercapnia patient is having hypercapnia or the symptoms of hypercapnia, so the default setting, they will start immediately by default the higher rate and only the higher rate and maybe higher tidal volume if you select the mode of its volume control. So this is the new patient. After that, we have also in ELISA 800, we have something called Fast Protect. As you see, it's the new features in our ventilator in our ELISA 500, which is really focusing in the protective of the lung injury. We will have continuously measuring the plateau of the patient, the delta V of the patient, and also the tidal volume compared to the ideal body weight for this patient. And you will have in the left side, you will have what? The volume and the pressure volume loops, which is really focusing in the restrictive or the obstructive disease, or what is the change of the lung volume for this patient. So this is the Fast Protect features. It's only founded in the ELISA 800, which is really helping for the protect the lung injury and giving a continuously measurement for the patient. Also, we have the Fast Wean. What is the Fast Wean in this ventilator? It's also there is a multi barometers that focusing in the weaning for the patient. For example, continuously calculating the rapid shallow breathing index, the exhaled spontaneously tidal volume, also the frequency spontaneous, and the BO01, which is continuously calculating, giving the end user or the RT or the doctors signs for that if the patient is ready for wean or to continuously weaning the patient. This window is the called Fast Wean. So also in ELISA 800, we have a trend. Trend, it's the continuously having numeric and the graphic together data, which is retrieving the data up to 72 hours or 4,500 event back. You can retrieve it to the patient. This, they will save what? They will save the data, all the setting for the patient, also the graph for the patient. That means helping the end user, the RT, the doctors to do investigations about any incidents happens, or if they are interested to do some research in the patients. As you see here in the main screen, we have the numeric and the graphic screen. As you see, you have up to 10 pages you can select it by your finger move. You have in the left side, you have the waveforms, the three types of the waveforms. We have a pressure, volume, and the flow. We have in the left side the measurements for the patient. You can select the most common measurement that you are focusing on it. And we have here the external measurement can be for the mechanics, lung mechanics. As you see here in the slide, we have the ELISA 800. We have the unique and the new features, which is lung view. What is the lung view helping? As you see, you can find it here in the main screens. In the main screen, all you need from you to select it and by your finger, then you will have what? Continuously showing the lung view for the resistance compliance for the lung, upper lung, and also the compliance for the lung resistance and the compliance for the upper airway continuously measuring. So also they are showing you the diaphragm view for the patient. This help you for if figure out if the patient having issue with the resistance in upper airway to solve it, for example, suctioning or giving some bronchodilator or any obstructive happen to this patient or changing in lung compliance to the patient. This is a great tools to helping the end users and the doctors to figure out the issue for this patient or helping to improve the outcome. So as you see continuously for the features of the ELISA 800, as you see, we can select from in the right side, you can select what's the setting you like. It's very one step from you by your finger. You can slow and fast adaptation the setting that you are selecting. For example, tidal volume, rate, any kind. You just need from you to scroll out, and they will give you the data exactly, and you confirm it by the raw down. Here in the night mode, as you show here in the night mode, there is a two night mode. If adult category, you will have the black screen with the major data that the measurement, for example, the tidal volume, the rate, the minute ventilations. Also, they will have continuously measuring the cuff pressures, the tidal CO2. If you connected the pulse oximetry, you will have continuously measuring or monitoring the SpO2 and the heart rate. Here we have a really great features helping the end user RT and the doctors to minimize the infections come from the ventilators. It's the called hygiene standards. What is the hygiene standards? It's the all that accessory or all the connection that used to the patient and requiring from the end user RT or the doctors to change it. As you see, as you know, as a RT or as a doctor, the HME, they need requiring, for example, the guidelines is the after 24 hours, you need to change it. So we have a new standard here, hygiene. You can select all the accessory or all the types that you have to do for change, suctioning system, nebulizer, tube, circuit. Just from your side, you need to select the date or apply the guidelines that you have it in your hospital. For example, the tube after 30 days, just select the circuit tube for the patient ventilator after 30 days. Then after 30 days, the ventilator, they will give you alarm to change the circuit. If the HME also, they will give you alarm or signs that please RT doctors change the heated or the HME. It's a really great options to minimize the infections and helping the RT to apply his standard in the ventilator. Here Also, we have in ELISA 800, as you see the main screen in the right side, and we have a great options in ELISA 800. It's all the flow sensors, expiratory valve membrane, as you see here in the right side, the white circuit, and inspiratory valve in the blue circuit. All this valve and the flow sensor, it's the built in, so it's already inside the ventilator. No need from the RT or from the end users to change it. Only need from them to sterilize it with the specific temperatures, 130-degree autoclavant. So this one, it's really helpful for the RT, for the doctors, to just minimize the infections. Also helping for reducing the cost operative for any operation of the ventilator operations. As you see here in the left side, how to remove it and send it to the CSD, then they will clean it, then they will return it and connect it back to the ventilator. This one is helping for end user to not consume a many accessory and helping also for accuracy of the measurement for the ventilators. Here, as you see in the ventilators, we have a new color. In our ventilator, we have a new color. In the blue one is the inspiratory valve, and the white one is the expiratory valve. So this one, it's already built in, only require from the end user just to sterilize it and reconnect it and reuse it again. And also the circuit here, it's open system circuit. Any kind of circuit can be used for the patients. As you see here, we have in the expiratory port, we have a two port, one for the transpulmonary pressure monitoring and the left one for the cough measurement. Both of them, I will explain it inshallah next in the slide. In the for the inspiration board or the inspiration board, we have in the right side, we have a nebulization board for giving a pneumatic nebulizations for the patients. As you see here in our ELISA 500, we are the first ventilators or first company that developing PISO. What is the PISO? Is the transpulmonary pressure monitoring. Transpulmonary pressure monitoring is the great tools for measuring the optimal beat for the patient by measuring the difference between the transpulmonary pressures and the thoracic pressures. So this one give a great tools to measuring the optimal beat for the patient. How we can apply it is by the NGT. You need to insert the NGT behind the heart. Then there is a sensors. This sensors measuring the difference pressures between the thoracic and the pulmonary pressures. Also, we have a new and the great features called a cough Scot. What is the cough Scot? As you know, there is a normal method for inflating the balloon for the endotracheal tube is the by cough manometer to measuring the cough manometers or by the syringe. So this one, this is the traditional way for the RT or for the end user to use it. So here in our ventilator, we have a new and the unique features, only sample line from the balloon to the ventilators. Sample line, you can select here in the left side, you can see select how much the centimeter of water. that you need to keep the balloon inflated. For example, 25 centimeter of water. If you selected 25 centimeter of water, so if there is any leak or the cuff is deflated, the machine already inflate by himself. So there is no require from the RT or from the doctors or from the end user to inflate it again, because the machine they will inflate it continuously and minimizing the leak. What is the outcome for keeping the balloon all the time in the good and the proper centimeter of water or the pressures? To prevent the secretion back to the lung. Also, minimizing the ventilator associated pneumonia, which is really a great option to help minimizing the length of stay for the patient and decreasing the infections related to the ventilators. What is the name of this? Is the cough Scott features. As you see here continuously with the new features, we have something called beep, best beep tools. Here, from the maneuvers, we have something called best beep tools or the beep finder. It's the great tools to measuring the optimal beep by measuring the pressure and the volume loops. How you can measuring the pressure volume loops? There is something called inflections point and the deflections point. The machine they will look for the safest zone for the patient and the safest window for this patient. After that, they will give you the recommendation how much the beep should be selected to this patient. It's really great tools to measuring the optimal beep for the patients. From the maneuvers, you can select it here, the beep finder and the best beep, then you can do the maneuvers. After that, you will measuring to you through the pressure, the inflections and the deflections point. Then they will select the safest zone for the beep, and then they will give you the recommendations beep for the patients. So continuously with also the features and great tools for our ventilator, we have also a new technology. It's called sensor technology for the CO2. It's the LEO cap. It's the LEO cap. It's through the entitled CO2 we can measuring the volumetric carbonography, showing the anatomical dead space, and also the alveolar dead space, continuously measuring this. It's really great tools to continuously measuring the anatomical dead space and the alveolar dead space under constrictions. Also, they can calibrating during these operations. Also, they will showing you the entitled CO2, the waveform continuously measuring here, and also you can analyzing the expiratory and the inspiratory CO2 while the operations. What is the name of this technology? Is the LEO cap. Can be found in the ELISA 800. It's a great tools to measuring the anatomical dead space and the alveolar dead space all the time and showing you in the main screens. Here you can see in the sensor technology, you need from you to have the Massimo. To have this technology, you need to have the Massimo mainstreams analyzing the expiratory and the respiratory CO2, need adapter, and the need manual calibration procedures. As you see in these pictures, we have the Massimo entitled. Also, we have Massimo side stream. Is the same, different, but different pulse oximetry or different entitled CO2. They need from you the sample line and the side stream CO2 sensors and the sample line with the airway adapter to have these options. As you see here, we have the modules for the LEO ELISA. It's really focusing, it's a multi-gas analyzer. It's the module connected to the ventilators. We will have the automatic gas identifications, analyzing the CO2, also performing auto calibration during the operations, analyzing the expiratory and the inspiratory CO2, can have gas retain connections, and the sample gas outlined there. As you see, the Leo clock for the CO2, the Leo clock is the adapter, and CO2 it's the adapter for the saturations monitoring. It's by the Massimo monitor, can be analyzing the SpO2 and the pulse and the heart rate. That means you can analyze all this information in your main screen in the ventilator. You will have the pulse, heart rate, SpO2. So it's the small monitor during the transport or during any kind of a procedure. You will have continuously measuring monitor if there is no monitors. What is the adapter? It's the Massimo. You need to have the Massimo to have all this informations. As you see here in the sensor technology, if you connect the saturations sensors from the Massimo, we will have, you can adjust the alarm limit. You will open for you the window for the average of the FI2, average of the saturation and the heart rate here in the blue. You can see it here, continuously measuring the average level for the saturation and the heart rate, adjusting the therapeutic range for the patient. Also, you will have analyzing functioning, plus you will add to you the target saturation in the for the clock. You can add that target saturation 94, 97, for example, if the patient goes below the FI2 already adjusted by himself, by the machines. So the FI2 auto adjusted by the machines. It's really a great options for the pediatric neonatal population to have a continuously measuring the heart rate, the saturations, the acceptable range for the saturations. If the saturation goes below or above, the machine can be auto adjust the FI2. And also you will have a window, a clear window that the average or the continuously measuring for the patients. In the ELISA 800, we have continuously with the unique features. In ELISA 800, we have a nebulizers, can deliver the nebulizer by two ways. By the integrated mesh nebulizers, which is really a great options. Can have a mesh technology, drop the size of the particles less than 4. Can have the time range between 1 to 60 minutes per for the therapy time. Also synchronizing the inspiratory phase or the mandatory spontaneous trigger during the therapy ongoing. Also, we have a pneumatic nebulizer. Pneumatic nebulizer, you can find it in all our ELISA 800. So this one, it's really great options. You can suggest the flow technology or the pneumatic flow technology from the size 8 to 6 to 8 micro. The flow depends in the capability used from 6 to 8 liter per minute. The adjusted time 1 to 60 minutes for the therapy. Also, they can synchronize the inspiratory phase and the mandatory phase for this patient. It's really great options. You have the two ways for the ELISA 800. Mesh nebulizer, pneumatic nebulizer can be giving. So this really a great options for helping the patient by the nebulization and improve the patient's outcome. So as you see here in nebulizer connections, you will find it here in the manual how you can connect the integrated mesh nebulizer As you see in the graph, the mesh nebulizer should be after the HME. You will connect it from the back side. In the back side, there is a modules. You need to connect the mesh nebulizer, then connected the oxygen and the nib kit here after the HME. Then go to the main screen, selected the time of the therapy and how much the flow that you need. So this the connections clear for the mesh nebulizer should be after the HME size. Here you can see in the mesh nebulizer, you can have it from the nebulizer from the functioning. In the main screen, you have a nebulizer. Nebulizer, we have a two nebulizer options, pneumatic nebulizer and mesh nebulizers. So depend on what you are delivering to the patient. If you selected mesh nebulizer, you need to connect it proper connections to the patient by closing the cap for the nib kit and medication chamber, this one in the B side, and the patient connected adapter. You need to have the adapter, then connected by the circuit, then start your therapy by selecting the on and selecting the time for the therapy, then you can start the nebulizations. So as you see here, for the second nebulizer options, we have a pneumatic nebulizer. It's the regular and the standard one through the inspiratory limb. You need to select the pneumatic or the nib kit, and then start selecting the after the HME. You have to put the inspiration or the nebulizer. Then you need to select what the nib kit, as you see here in this slide, the nib kit, any kind of nib kit, and you have to select and insert or connected the tube here. Then start with selecting the time of the nebulizations, and then select the on to start your therapy. So after we finish that, we will move to the application invasive ventilations. So as you know, for any kind of mechanical ventilation, there is intent of use of the invasive ventilation. There is the indication for using the ventilator. The most common is the airway connections and the setup, the background informations, and what is the ventilator mode IV. As you see, in the next coming slide, we'll explain about the mode and what is the difference or the unique for our modes. So as you see here, the invasive ventilation, we have all kind of modes. All kinds of modes. So there is a spontaneous ventilation mode, including CPAP, pressure support, dynamic, high flow, proportional, also pressure support. We have hybrid ventilation mode. This one by the logarithm, dynamic bi-level, flexible bi-level. We have a closed loop ventilation, work for breathing mode. We have a special mode, it's the CPR mode. We have a unique and first options is the bronchoscopy mode. So as you see in the ELISA 800, intent for use, it's the great options for ELISA 800 are designed for all patient category, adult, pediatric, and the neonate, starting from 0.3 grams up to 6 kilo for the neonatal population, as you see in the tables. For the children, from 3 to 150 gram, and for the adult, starting from 30 to 500 kilograms. So that means the ELISA 800, it is really can support all patient categories, starting from severe premature baby, starting 350 gram up to 5,000 ml for the patient. It's really a great options. Plus, or respiratory support can provide by ELISA 800, which is non-invasive, invasive, high flow, helmet therapy. Also, if the patient endotracheal or endotracheal or the tracheostomy patients. So, as you see, intended use of the invasive ventilations. As you know, the patient usually will not get intubated immediately. You need to have a sequence for the respiratory support, starting for trial of the high flow. Then, if there is no improving from the high flow, then you can escalate it to the mouth mask, non-invasive ventilation. Then if there is no improvement, then you can move to the invasive ventilations. So after you finish all this one, we'll go back to the de-escalation to the weaning process for the successfully extubations. After you extubate the patient, maybe patient requiring the NIV mask, or to escalating to the high flow, or send it to the home care system. So as you know, and it's really common, this sequence for the any end user, starting from high flow, escalating the therapy up to intubated the patient, then we'll look at for the weaning process. So as you see here, intubation prevent aspirations is the proper way for the gut patient intubations inside the vocal cord and inside the tracheostomy, not here in the larynx, which is prevent the aspirations process. What is the intubation, nasal, oral, tracheal connections? As you know, the intubation is for the long-term ventilation intervention. A critical operation for the patients is the basic information for the ventilations. Also is the unconventional positioning during the operations for reflux risk, full stomach or insufficient stomach muscles, or for the airway obstructive. So this one is the airway connections and the setup for the patients. Also, in this slide, it's focusing about what is the unheated tube system. So as you know, in the unheated tube system, that means we are using the HME filters. So the HME filters only requiring from the limited 24 hours working time the patient. If the patient is for short term intubations, we are recommending the HME filter for not the active humidifiers. Also, as you know, the connection for the HME is very clear. Here you can see it after the YBs for the patient. You can connect the HME for the patient. It's really mostly for expected short ventilation phase after the operation, less than 24 hours. Unheated tube system is used for the heated for the humidifier, not allowed to combine the active humidifier with the HME filter at the same time. This one will increase the risk of the resistance for the ventilation systems, and also is not also maybe improving or challenging for the water condensations for the circuit. So it's not recommended to connecting together the HME and the active humidifier. So you have to select one of humidifications. We are recommending if the shared for the short-term ventilation HME, if it's the really patient having large amount of secretions, thick secretions, or long-term of ventilation, that means you have to shift the patient to the active humidifiers. As you see here in the breathing system, background information is the basic ventilation information about the back ground information gas exchange, starting from the oxygen from the pulmonary alveolars, then carry out by the red blood cells. Then these blood cells carry out to the main organs such as the liver, lungs, brain, skin. Then after that, they will release the cells to the carbon dioxide back again by binding to the blood cells. Then the blood cells enter again to the lung. Then they will remove the lung by the exhalation, the carbon dioxide. So as you see here in this screen also, we have the alveolar gas exchange, oxygen, carbon, and how is the diffusions concept or diffusions concentrations by alveolar go air inside the red blood cells, or also the CO2 go from the red blood cells to the lung again to remove it by the CO2. So, by this informations, as you know, for also the ventilator, you have to enter all the patient information. Why we need to enter all the patient informations? It's really, you have to enter the patient body weight, the height, because the ventilator, they will calculating immediately the ideal body weight for this patient. Why we need to calculating the ideal body weight? Because we have a smart logarithm mode. It's really depend in the ideal body weight, and it's really predicting the continuously predicting the minute ventilations and the tidal volume for the patient. So that is really helpful for the patient to having accurate information. After you enter the ideal body weight for this patient, they will calculate the amount of the drugs they needed if you have drugs, for example, the anesthesia drugs, or the calculation of the dead space volume, as we explained it before. Also calculating the tidal volume and calculating the O2 metabolism for the real body weight. So it's really helpful to enter all the patient informations. Also, we have in our ventilator ELISA 800, we have a tube compensations. A tube compensation, as you know, a tube compensation is functioning to compensate the resistance in the tracheal or the endotracheal tube. It's really helpful for the if the patient having a different diameter of the endotracheal tube. What is the outcome for turn it on the tube compensations? It's reduce the work for breath, may produce the auto triggers related to the length of tube, endotracheal. Also, if the patient having related to the diameter of the tube, as you know, you have a window from 4 millimeter of water, millimeter of for the endotracheal tube up to 12 millimeter. So we have also you can compensate it, the diameter and the compensation starting from 25% up to 100% compensation patient can have. As you see in the right side, we have the waveform for the brushers without tube compensation, and with the tube compensation is more easily and more having the patient faster, easy for inspiration effort. How we can found the tube compensations from the patient. After you selecting the patient in the main screen, you need to select the interface, for example, the endotracheal tube. Then you have to select the diameter of the tube, how much the diameter for the patient endotracheal or the tracheostomy. Then you need to select the compensation on or off. Then you need to select how much percentage you need to need from the ventilator to compensate. As you see in the graph, the compensation is already on here. It's really great option applying this compensation for the mandatory ventilation and in the spontaneous breathing. For Here, the tube compensations is the continuously for the other. We have expiratory compensation and we have inspiratory compensations. So we will stop here. We'll give for 10 minutes break. Then we'll continue our lectures about the moods, about the more features in our ELISA. So now is 10:50. We'll back again by 11 exactly to continue our lectures. Thank you so much. If any mention, please, if any questions, please write it in the chat. We will answer it, inshallah, in the last 10 minutes. Thank you so much. بخصوص الأسئلة أرجو كتابتها في الشات. في أي سؤال أي استفسار كتابتها في الشات وإن شاء الله راح نجاوب عليها بإذن الله. Thank you. السلام عليكم. Back again. واضح الصوت؟ أي مشكلة في الصوت أو أي حاجة مو واضحة السكرين الشاشة واضحة؟ إذا مو واضحة please write it up في الشات. So to continue our presentations, we stop here in the compensation functioning. As you know, in our ventilator we have a configurations system. The configuration you can add all what you are looking for. For example, if you are asking for the compensation, you can make it on here or you can make it off. So in the main screen, you will not find or found the compensation. So we are recommending for the end users for all the RT to start with the configuration, set it up, all the information, select the configuration from the main, then from the availability, then you will have the compensation, configure the compensation by on or off, then make a save in the downside here. After that, you will find what you are changed in the main screen. So this the for the tube compensation or any information, for example, the bronchoscopy options, you can make it on or off. It's depend in the end user or the automatic patient deductions, all these informations. So as you mentioned before, for the hygiene functioning, for the frequent exchange the patient gas contaminated part, as you know, every ventilators there is a part that they need from the end user to change it by the time for 24 hours. For example, the breathing circuit, for the heated circuit, HME filter, suctioning system, only need from the end user to adjust or adapt the time for the changing based on your guidelines or hospital guidelines. For example, the HME 1 day, you need to select it here 1 day. For the breathing circuit, every 7 days, or BRN, or after 1 month. If you adapted all your guidelines or protocol that you applied in your hospital, apply it here in our ventilator, then they will give you continuously alarm that please RT, please nurse, please doctors, change my HME, change my breathing circuit is the due time for this. This is really helpful for continually decreasing the infections comes from the heated circuit or from the accessory that used in the ventilators. How we can find it here from the configurations, parameters, value, you will find it here in the configurations. For also the new features, we have a new parameters. We have options is the expiratory RAM mandatory. As you know, the expiratory RAM mandatory can be can be choose by active or on or off, or by percentage how much you need the RAM expiratory RAM active by 100%. That means it's very soft for the expiratory phase, or you want to make it very strongest RAM expiratory RAM as 20% from the expiratory time. So it's really great options to help for the maintain or improving the trigger for the patient and giving the patient a great time or a long time to exhale, probably if the patient having local collapse in airway or flow limitations. As you see here in the graph for the expiratory RAM mandatory, if it's the on, or you can see in the gradually pressure decrease and the expiratory flow curve raised by the phase splinting of the airway. So this one, it will help you for reducing the intrinsic beep and also remove all the air or the exhalation, all the air from the lung. How we can activate the expiratory RAM mandatory? You can see it here from the ventilations. If you select the mode, you will have options here, expiratory RAM mandatory. You can make it on, or by percentage, by 20%, 50%, or 100%. It's depend on what you are seeing in the waveform. If the waveform there is the exhalation is very smooth, that means there is no requiring from you to make the expiratory RAM. But if you see that patient is really need more exhalation, you can change it by the I time, or you can change it by the expiratory RAM cannula. Here you can see the expiratory RAM is the on, and the selecting the negative 20%. So how we can explain after the inhalation phase finish by 20%, the exhalation they will start. So this one make the exhalation is longer and giving the patient is more time to exhale. As you see here, is really a good example or a good tables of figures. You can see here, patient RAM cannula is negative 20, so it's very smooth exhalations, very slow, and giving the patient slow exhalation, giving the patient enough time to exhale and remove all the air. But if the patient is the exhale RAM is off, you can see is the exhalation is very sharp and fast for removing the air. Continuously with our ELISA 800 features, we have also something called automatic suction routine. We have two ways of the suctioning routines. We have open system suctioning, and we have a closed suctioning. In the open suctioning routine, you can see what they will do. The open suctioning routine, they will do many things. One, pre-oxygenations. So they will give more oxygen based on the selected FI2 that you need increased. Also, they will give you the time for the suctioning procedures. Then they will give you 2 minutes for the post oxygenations. Also, you can stop the functioning at any phase. You can terminate your suctioning at any phase that you think that you have to stop. So we have a three maneuver consists of 3 phases: pre-oxygenation, suctioning, and the post-oxygenation for the open suctioning routine. Here is the explanation what they will do. The pre-oxygenation users increase the FA2 concentrations by the desired value. So it's helping for the patient during the suctioning, they not desatting during the procedures, and stabilize the patient during the procedures. Also, we have the second suctioning routine is the closed system. Closed system, you can apply the performing the suctioning routine with the closed suction system. You can set the oxygen concentrator and apply it for 120 seconds. Also, you will have some audible alarm is disabled, but you can also silence it during the procedures. You can see here in the figure, we have the automatic suctioning routine from the functioning. You can go to functioning, then selected the automatic suction routine. Then you have to select which type of the suctioning you need, system open or the closed. Then how much the FiO2 compensation you need to increase the FiO2 during the suctioning, pre-oxygenation, post-oxygenation, then start the suctioning. After that, you will have it here in the main screen, the running of the the pre-oxygenations, and also they will show you the time for the pre-oxygenation, how much the time remain for the pre-oxygenation and the suctioning time. From the functioning, automatic suctioning routine, then you select the type of the suctioning. Here, we need to explain about the ventilation mode. As you know, from the configurations, we are only a medical company, or the ventilators, unique ventilators, ELISA 800, and all ELISA family, we have 28 mode. Imagine 28 mode you can select it in our ventilators. By the configurations, just you need from you to select the type of the mode. For example, children NIV, then you can move by your finger, just press here, move what is the mode you need to see it in the children NIV main screen. We have in 800, we have all types of support. Adult IV, you can select it from the right side. Adult IV, then you will open for you 28 mode. You can select the 10 common mode that you are using in your hospitals. Adult NIV, nasal cannula, plus we have the helmet, we have a neonatal IV, we have a neonatal NIV. So just the need from you to select the selecting the mode, then you will see it in the right down. You will see the explanation about the mode, the concept of the mode, and what is the name exactly in the different company. So this one is really a great options for you you need to go in the configurations and moving to the ventilation and select all your mode that you need to see it in the main screen. So as you see here in the ventilation mode, in the 800, as you see in the red market, we selected all the 10 mode that is the most common mode that I need to see it in the main screen. If, for example, I don't want to see the dynamic process support, I can remove it and select what is the mode I need to see it. So you have a wide range of the mode, 28 mode, including spontaneously mode, assist control mode, advanced mode, and we have a unique mode such as a bronchoscopy mode and the CPR mode. What is really need to explain it later. So is the patient breathing? So in next slide, we will see what is the really a great options for in our ventilators. Starting with the mode, as we mentioned before, we have a 28 mode. So you can select what you like. For example, we have a volume control mode. It's really a clear mode for every end user, for the RT, for the doctors, for the nurse. Volume control mode, it's clear, it's similar to the CMV mode. It's the conventional time cycle and volume control ventilation. So that means you have to set the tidal volume and what you need from you will see the pressure is the really variables. You will have the fixed tidal volume and the pressure will be variable. So it's really mode, and it's a common mode for many patients, especially for adult or a specific patient. As you see in the main screen, you need to go to ventilations and select the ventilation, volume control ventilation, and you will have here the main settings. You need to adjust it based on what? Based on your patient category and weight, ideal body weight, and the demand for the patient from the ventilations, and you can select the mode that you are looking for. We have also the pressure limited ventilations. It's the specific conventional volume control mode that is used a pressure limit, pressure max. You can see it here also in the ventilations options. So we have by level, we have all kind of mode. You have the pressure limited ventilations. You can select it. The only difference that you have the B max here is the really difference from the volume control that you can select the B max from here. We have, as you know, we have the SIV mode, which is what is the SIV mode? Is the 2 mandatory breath in 2 mandatory breath, as you see here, 2 mandatory breath. In between, the patient can breathing spontaneously based on what? Based on the selected pressure support that you are giving to the patient. So this one is really helpful. Is the first stage for the weaning process, helpful for the patients to stabilize the oxygenation and reduce the work for breathing. As you see here, you can find the ventilations from the volume control SIMV. Volume control SIMV from the ventilation mode, and you can select all the settings that you are looking for, plus the pressure support for the spontaneously breathing. We have, I think I have questions about it. We have optional volume controls. What is the optional volume controls? Is the optional volume control is the mandatory minute ventilation. So it's really focusing in what? It's focusing in the they will open window for the minute volume, mandatory minute volume. Then they will adjust the breathing based on the window that they have optional mandatory minute ventilations. It's really great great mode for adult populations. As you see, optional volume control ventilation with the mandatory minute volume as the control variables. As you see here, if the patient breathing spontaneous, they will have the pressure support. The optional volume control, you will have all the settings from the ventilations plus the pressure support if the patient having what? Breathing spontaneously pressure support. If the patient is requiring minute ventilation is the less than what they are targeting, that means the support for the patient they will be less. Also, we have the flexible volume control. Flexible volume controls, it's the represent a technological advancement over the optional volume control. Using the set respiratory rate, this would use a set minimum minute ventilation. So if the minimum ventilation is the less than what is the target, that means the patient they will receive the mandatory breath. If the patient having larger minute ventilation or more than what the acceptable minute ventilation, that means they will give the mode, they will give chance to the patient to breathe spontaneously. This is the difference between the flexible and the optional. As you see here, we have all the settings, the same settings, flow triggering, Bmax, and you can select it from the ventilations mode. We have pressure control ventilations. As it's really common mode, it's also common use for the pediatric neonatal populations. So we have a fixed tidal volume. and the set tidal volume is determined by what? The upper and the lower pressure level is dependent on the over pulmonary compliance. So from the PEEP level and the PIB or the pressure max, they will depend the tidal volume based on the compliance and the resistance of the lung. It's really common mode and preferable use for the pediatric and neonatal populations. As you see here, in the pressure control, we have the ventilation mode. You can see it all the set mode here, and plus the pressure inspiratory, we have the flow and the beep setting. So it's really a normal set. Just need from you to add the expiratory ramp for the patient if you want to make it off or on based on the exhalation or the patient conditions. Okay, so as we know, we have also advanced mode. In ELISA 800, we don't have a high frequency modality. We have it only tomorrow for our ventilator tomorrow. The lectures tomorrow is the Leone plus high frequency. But in ELISA 800, we have all types of mode. The advanced mode here is the ABRV mode. So we don't have high frequency options. We have it only in Leone plus high frequency. What is the lectures? Inshallah, tomorrow we will explain the Leone plus. So I think I have questions about it. So the advanced mode here, ABRV mode, as you know, ABRV mode is very advanced mode. It's modified bi-level mode that allow the spontaneous breath to occur at the upper pressure support level, which is usually maintained throughout the long inspiratory phase. So that means the patient, they will breathe inspiratory pressure support spontaneously here in the upper level. It's really great options for the ERDS patients, severe ERDS patients, and showing a promising evidence that improving the outcome and the oxygenation for the patient. So as you see in ABRV, we can select all the time the inspiratory, the time low, low, pressure high, and the inspiratory time low, and you can select it here. And what is the great things in our ventilator that you can select the setting by point. So if you want to select the time high, is you can select it by 0.1, 0.2, 0.3. So it's really great options, not like 0.1 or by 1 or by 2. So it's really great to have accurate adjusting setting and management. So this is the explanation about the ABRV. What is the ABRV? It's the airway pressure release ventilations. It's like a bi-level mode, which is the inverse inspiratory to the expiratory time ratio. Patient normally breathes spontaneously in upper pressure level. CO2 is eliminated to achieve by briefly lowering the airway pressure to the lower pressure level. At the same time, the short pressure release phase are intend to prevent the collapse of the lung area that are ventilated more slowly. As you see here, the pressure release, automatic release, and again back to the pressure upper pressure level. So the patient, they can breathe spontaneously in the upper pressure. So this one advanced modality. We have also other mode is the pressure SIMV mode. So this one is very common combination of the time cycle pressure control that allow the spontaneous breathing. It's the pressure control plus the SIMV mode is very common mode to mandatory breath. Patient can breathe spontaneously in between. It's the first stage for the weaning. You can see here the pressure control from the ventilation. You can select the setting, also the pressure, the flow triggering, and you can add the pressure support. We have the bi-level. Also, we have the bi-level pressure. It's the pressure control ventilation that allow spontaneous breathing at any time. It's the combination of the time cycle and the pressure control ventilation that allow breathing, spontaneous breathing at both pressure level. It's really great options. So the patient then can breathe here in the upper level, or they can breathe in the beep level. So this during the mandatory level. Also during the spontaneous, patient can breathe also spontaneously. So this one is usually delivered with the pressure support for the ventilations. As you see here, bi-level mode, you can select the pressure higher and the pressure beep, and you can select the trigger, and plus we have the pressure support for the spontaneously breathing. We have also the bi-level spontaneously time. It's the different than the bi-level. Why? What is the difference? Because we have the technology advancement over conventional bi-level. If the patient, what is the difference between the previous mode and this one mode? If the patient fails to breathe spontaneously during the cycle of the time of the cycle of breathing, the machine they will initiate a conventional bi-level breath at the end of the calculating cycle time. So this one, if the patient got not able to breathe spontaneously, so the machine they will take over and they will initiate the machine breath. So you can see here switching between the control and the support. You can see here is the control, but the patient is immediately switching to the support. But if the patient fail, then machine they will switch back to the what? To the setting that you set it, the pressure control or the bi-level or the mandatory breath. CPAP breath, it's really a common mode for the continuously positive airway pressure. Also, we have it also in our mode. You can see it in the ventilations. FI2, beep, and the flow trigger. You can have it here for the oxygen, for the CPAP to improve the oxygenations. We have pressure support breathing. As you know, the pressure support ventilation is really helpful for the overcome the resistance of the airway, and it's also the great stage for the weaning phase and before to extubate the patient. So this one allow the patient to breathing and allows to deep breathing. So this one is very common mode for the patients as the pressure support ventilations. You can see you have the setting here for the ventilation, pressure support, flow triggering, beep, and FI2. Also, in our ventilator ELISA 800, we have a unique ventilator mode, which is the dynamic pressure support. What is the difference between the pressure support and the dynamic pressure support? Dynamic pressure support is the pressure is deliver a dynamic manner for each breath. That means there is no fixed pressure support. It's depend on the patient effort. If the patient need 8 of a pressure support, they will give 8. If the patient need 10 pressure support, they will give based on the patient target or the target volume. So this is really a great, they will save window for automatic adaptation of the mandatory breath. So what is they will do? The pressure support is delivered in a dynamic manner for each breath. The level of the pressure support delivered is adjusted to meet a set target volume. As you know, the pressure support or the spontaneously breathing, the patient need 5 to 7 mils per kg. And you need to look at for the breathing or the work breathing of the patient. It's the higher, that means they need more support. If the lower, that means less support. It's really a great mood to keep the patient on that and observing the weaning phase. As you see here, you can having the beep tidal volume for the dynamic bilevel because you have the the target tidal volume, as we mentioned, the spontaneously breathing, and the pressure you will be up and down to deliver the set tidal volume for this patient. We have also the proportional pressure support ventilations. It's the pressure support is delivered at the level that proportional to the set degree of the compensation required to the relation to the resistance of the flow. So this is the proportional based and back to the resistance of the flow support and the airway support. That means the volume support. They will give you the pressure support. It's really a unique and the first mode that we applied here in our ventilators. You can see here we have the beep, flow support. You can suggest it and the volume support, so you can adjust it based on the patient demand. Dynamic bilevel is the BRVC mode. Dynamic bilevel is the BRVC mode, which is only the different terminology is the same concept of the BRVC mode, only the different terminology. Dynamic bilevel, it's only pressure. They will deliver the tidal volume with the lowest pressure that required based on the patient resistance and the compliance. So in this dynamic bilevel, it's only at the pressure support for the spontaneously breathing. But if you are looking for the pure pressure BRVC mode, you have to select the mandatory bilevel. We will have it in next slide. See, you can see the dynamic bilevel is the ABRVC mode. Only the difference that means you have pressure support for the breathing if the patient breathing spontaneously. So if you are looking for a mandatory, that means you need to have mandatory BRVC. We have also a unique ventilator mode, which is work of breathing mode, work of breathing optimized ventilation. This a great mode is universal mode promoting a spontaneously breathing and affording adequate minute ventilation. So this is the safe zone for the minute ventilation based on the volume and the frequency. They will give you the target of the minute ventilation. Based on the target, how we can calculating the minute ventilation is depend in the modified Otis equations. So this one is the smart logarithm. It's already giving you the safest window for the minute ventilation. Based on that, the patient up and down, the breathing up and down to have the target minute ventilation for this patient. It's really great mode. As you see in the minute ventilation, you have it here. You have here the graph for the safest window for the minute ventilation. Here the volume, and here for the frequency, and here the safest zone for the minute ventilation. So based on the height and the minute volume target, you can enter it. So the ventilation, they will up and down to achieve your safe window of the minute ventilation. It's really smart logarithm mode, and they give you a clear sign that the patient is really having adequate ventilations based on the minute ventilation target and the height. That means you need to calculate continuously the ideal body weight. As you see here, the work for breathing is the promoting spontaneous breathing and avoiding adequate minute ventilation, breathing pattern with the optimum energy efficiency and compliance with the specific lung protections rules by applying the modified Otis equations. So this one, what they will do, they will promote reducing the negative work for breathing, promote the spontaneous breathing therapy, and prevent the dead space ventilations. How we have a specific point for the mode, that means the work for breathing ventilation is not available for the pediatric patient. Is not available for, so that's only for the adult populations. Always use the parameters MV target and adapt the minute ventilation setting. Also, you need to change the body weight or the height for the patient. We have also the new mode is the adaptive lung protections ventilations. It's the contrast to the conventional ACV. The mode does not control the ventilation based on the Otis equations, but it's according to the current guidelines for the lung protective ventilation. So this mode is the really lung protective ventilation using the guidelines for the lung protective ventilation, not the Otis ventilation. As you see, the monitoring for the spontaneous breathing and the safest windows for the automatic mandatory breath. And they have open window for the pressure max and pressure max. You can see here for the mode, we have the adaptive for the, you need to select how much mils per kg you need to ventilate the patient to apply the protective lung strategy. For example, you need 6 mils per kg and you need to have the height and the minute ventilation target. Then you need to select the max. Then you will have the measuring parameters, the tidal volume based on the ideal body weight that you selected. This one is really great for protective lung strategy. You can apply it for the severe sick patient to have a lung, if the patient have ARDS or avoid the lung injury. Also, we have in mode options, we have a unique features. It's called CPR mode. So this CPR mode is the 2 level of pressures. As you know, the RT, it's the continuously bagging during the code or during the CPR is the rule for the RT to bagging the patient. So there is no requirement for the bagging all the time. Just switch to the CPR mode and select the pressures that you need to ventilate the patient and the beep. Then make the trigger off, and you will having in the red signs that how much the time for the CPR, and they will deliver the ventilation based on the interval time. Great interval time is 6 to 8 minutes, 6 to 8 seconds per minute. The machine, they will give a breath and they will give support the patient by the FI2. So as you see, the CPR mode, the ventilator setting automatically adapt the individual conditions based on the need of the recitations. So the CPR mode is only available in the adult patients. They will not be active during the pediatric and the neonate. What is the selected or the default setting that they will start? Bi-level ventilation mode. They will start with the 100 of I2, beep of 5, pressure of 20, but you have to escalate it or increase it based on the patient breathing expansions. And the inspiratory time, you can select the trigger. We recommend to deactivate the trigger because you are you are doing the chest compressions. So the window, they will active the ventilation mode highlighted by the red as we see here. So also we have in our ELISA 800, we have expiratory trigger functioning. So this one, it's helpful for the mini modes, like for example, the pressure control. You can make it on or make it off the expiratory triggers. This one make triggers, as you know, some patients, they need to trigger even in the expiratory phase. So the expiratory time is too long, adjust the patient and try always to exhale faster. This one, they will help for removing the air trap. As you see here, the expiratory trigger marketing. If you make the expiratory trigger 20%, that means the 20% from the inspiratory phase, they will take by the expiratory phase, and they will allow the patient to breathe, exhale more longer. Okay. Also, we have options in our ELISA 800 that mean the patient can freeze. By here, they can freeze the screen and analyze the data. They can analyze the data, what is the peak inspirated pressures, the flow. They can just freeze it here and they can scroll and analyze it. Also, we have great options. It's called bronchoscopy functioning. Bronchoscopy functioning is from the maneuver. As you know, some patient, in intubated patient or a tracheostomy patient, they need some bronchoscopy procedure. So they can select the from the maneuvers. You can move the bronchoscopy and activate it on. What the bronchoscopy do if you make it on? The bronchoscopy on, that mean the alarm message will be present, but some alarm are deactivated. During the procedures, the patient, they will increase the FiO2 options. FiO2 increase during the procedure, that help supporting the oxygenations. Also, they will do the huge compensation for the leak that comes from the tracheostomy or from the endotracheal during the tracheostomy. So the three things that bronchoscopy done: deactivate alarm during the procedure, increase the FiO2, and huge compensation that for the leakage, to maintain the minute ventilation for the patient and maintain the patient stability during the procedures. So as you see, also in alarm, we have an alarm in the right side. You can select all types of alarm. So you have the ventilations alarm, gas alarm, additional alarm, delays alarm, all kinds of alarm. You can have it. So you can set it up and adjust your patient. Here in the gas alarm, you can select the oxygen alarm up and down, in tidal, also the clock system for oxygen alarm, in tidal CO2 alarm. Also, we have additional alarm. You will have it more. We have also delays alarm. As you know, if you select the delays alarm, that mean you have the backup ventilations alarm. We have the apnea time for alarm. You can select it and activate it. So the backup ventilation, you can have it here in the right side. Just need from you, just select the backup ventilation if the patient is spontaneously mode. Select the backup ventilation, tidal volume, rate, inspiratory time, the race time. So plus the time backup and the time of the apnea. So this one, we can select it and adjustable. So this one for the ELISA 800 as lectures today. Sorry for I didn't identify myself in the beginning. I am Saad Al-Anazi. the manager of the marketing in Azir company and clinical applications. So we end our presentation today about the ELISA 800. So we'll open the mic for if there is any questions, and we'll try to answer it if there is any questions or concern about our the device or so I will open it now. If you want, you can write it up your questions in the chat, so we'll read it and answer it. Thank you so much, and we'll open the chat now. Thank you. Uh, okay. For the certificate, inshallah, after finish all the course, still we have a lectures tomorrow. After that, we will send by the email the certificate. Don't worry about it. So now we'll just open the mics for all. If you have any questions, you can raise your hand, please, and I will open the mics for you. Just raise your hand, please, and I will open the mics for you. Okay, any questions? Any questions? I will answer. For example, the chat, they give you what is the major difference between the flexible and optional? As we mentioned, the flexibles volume control, it's the depend in the minute ventilations. So they have the target tidal volume, you have the rate, but for the optional volume control, that means you will have they will focus more on the minute ventilation, up and down based on the minute ventilations. So what is the okay? We'll send for the materials, for the course materials. We will send it and through the website, and also we will send it here inshallah tomorrow the talk. So we will just ask if you. I open already the mics. If there is any questions, you can ask, please. I would like to know about. Do you have integrated system? Yes, for our ventilator, yes, we have a great options. Is the electrical impedance tomography. It's for the chest belt that is already connected to the chest. It's available for all patient category. It's really open window for the main screen for the lung and lung view. They can show you the air, it's the really well ventilated the lung or not. If it's changed the color to the yellow, that means there is a collapse or the fluid, so you need to adjust the setting. It's really helpful for the end user, for the doctors to reduce the x-ray procedures and improve the outcome of the patients. So okay. Yes, you can ask. Ahab, you can ask, please. Go ahead. Ahab. So yes, sure. About the evidency materials, yes, we'll send it all the informations, all the PDF for the presentation. I will send it through the about the inshallah during the email, and also about the WhatsApp. Yes, Badr Al-Mhedil asking about the another question: is the pneumatic nebulizer features available for the ELISA? Yes, pneumatic nebulizer features is available in all ELISA family. Yes, you can find it, but the mesh nebulizer is the optional procedure. Optional. What do you mean for automatic suctioning? Automatic suctioning, I mean we have a two a way for suctioning. There is options, as you know. The procedure of the suctioning, they need from you to pre-oxygenate the patient, then do the oxygenation, do the suctioning, then after that you need to oxygenate the patient again. So this one, if you select the pre-oxygenation or the automatic suctioning, they will give you the three phases. The three phases, that mean they will support the patient by oxygenation, increase it. Then during the suctioning, they will deactivate the alarm. Also, after the suctioning, they will increase the FI2 to support the patient and stabilize the saturations after the suctioning. This the I mean for the suctioning. So okay, yes, ask, yes. I cannot hear you, Yeshe. Can you raise your voice? What is the
about CPR
indication
mode,
for? Yeah. Yes.
about CPR mode, when done chest conversion, can you seat pressure or tidal volume?
For the suctioning routine, suctioning procedures.
Not in suctioning pressure. When seating or apply CPR mode.
Yes, yes, yes. Yes, the CPR mode is it's really a great options to have. The CPR mode is the two level of brushers. You can select it, the two level of brushers, and increase the FI2. Also, you can select the interval time for the brusher, higher brusher and the low brusher. So you can select it, for example, 6 to 8 minutes, and still you have a measurement of the tidal volume, spontaneously rate if there is a spontaneously, also the minute ventilations. Also, they will deactivate the triggering, as you know, because the patient is the continuously CPRing, is very difficult to maintain the triggering. This is the option for the CPR.
That not risk for any new drugs.
Thank you. Any questions؟ خلينا نرجع للشات. There is one question: if we need urgent suctions, do any patient then how we will do suction if the machine will on automatic? No, you have two ways of the suctioning. You have automatic suctioning, you have a manual. You can stop the suctioning anytime. So it's only open for you. You have the option is the only controlled by the end user. You can do the suctionings automatic or the manually, or you can stop the suctionings procedures at any stage and at any phase. There is one question about Ibrahim, the ventilator regulatory, the tube cuff pressure by itself. Yes, there is cuff Scott, means cuff Scott is continuously sample line from the ventilator to the endotracheal. Then they will inflate and deflate the cuff based on the set pressure that you select. It's really a great pressure. Can the ventilation measuring the dead space? Yes. As we mentioned in the early presentation, yes, we have a modules is the called Leo Clark analyzer. they can measuring the dead space, anatomical dead space, and the alveolar dead space. So it's really good tools to have alveolar ventilation for the patients. Yes. Okay. Thanks. So, okay. Still, we have 5 minutes, if any. The fast product, do you measure the mechanical power, a potential cause of? Yes, they are measuring, and you can have it continuously measuring the fast, the mechanical power as a delta B, the potential cause for the, for example, PIB, the potential, the delta B, the plateau pressures, all this one is continuously calculating. So, do you have integrated? Yes, I answered it already. So this one, we have Lovenstein planning the features and name according. Okay, yes, sure. We just follow us in the LinkedIn, in the website, and all our social media. You will have the update about our course, inshallah, upcoming course. Yes, we have another SIMV pressure control and called bi-level and made confused when about. Yes, the bi-level is different than SIMV pressure control. It's the bi-level is the unique features. It's helping for the patient allowing to breathe in higher pressure and level. It's two open two level of pressures, but there is a unique features on that. Pressure support, what is the difference between pressure support and the dynamic pressure support? It's really a great question. A different pressure support is the fixed pressure support. You select pressure support, PSV. So this one is the, even the patient is having any breath, they will give him, for example, 8 pressure support. Next breath, 8 pressure support. Next breath, 8 pressure support. But if you selected dynamic pressure support, no. This one, they will shift to the based on the patient compliance, resistance, and work for breathing. If the patient need or demand on 6 pressure support, I will give him 6 pressure support. If next breath, if the patients need more than 8 pressure support, the machine, they will give him 8 pressure support based on the what? Based on the minute ventilation target. This is the difference. The pressure support is the target, and the dynamic is open window for the minute ventilation to adjust up and down the pressure support to achieve the target of the part. So we have, you can, Abdullah Al-Hussein, yes, you can ask. تفضل. تفضل عبد الله. عبد الله. عبد الله تفضل نسمعك. عبد الله. طيب بنرجع للشات يعني Yes, في سؤال, there is one question, is there options for NIV and BO2 FI2 ratio and the plateau pressure? Yes. For the NIV, yes, we have continuously measuring. If you did the inspiratory hold or inspiratory hold maneuvers, we have the NIV, they will give it to you as MIB as a measurement. Also, we have no, the BAF ratio is not available, but the plateau pressure is continuously measuring. Yes, so the NIV and the plateau pressure is continuously measuring. Yes, just need from you to do the maneuvers for the inspiratory maneuvers. They will appear to you as a measurement. For the plateau, it's continuously measuring. Also. If we activate the CPR mode, there is no need for the end user to do the, yes, there is no need to do the, there is no need to do the manual breath. Just you need to select the desired pressures. and check the minute ventilation. If it's okay, then there's no need from the end user to do the manual breath. Does the BABC the same as the? Yes, it's the same. Yes. It's the only different terminology. Yes. So, okay, I think we finish our lectures today. Thank you so much. So, inshallah, tomorrow we'll see you at the same time at 10 o'clock. Please don't leave the WhatsApp group, because we'll send the link for the lectures tomorrow about the high frequency. So thank you so much. I really glad, and I am happy really for this attendance. So see you tomorrow. Thank you so much. Bye bye. Thank you.